need is 12 boxes wide. So the problem is, if you have only this section of graph paper left in the toolkit, this section's 10 boxes wide. That's not wide enough. So we really need 12 boxes wide. So if you have any toolkit space open with the blank graph paper still from Chapter 3, or grab a blank sheet of graph paper. Make that happen in the next 30 seconds while you make sure that you have your plan book filled in with tonight's practice work. We will talk about Schoology and that assignment expectation here later in the week, once we actually do some homework, and it matters. And then at your group, it would be beneficial to have a textbook or two out. I know some of you guys are trying to just use the screen, which is okay since I have two screens, but it is better when you have the book in front of you. So, wherever you're taking notes today, let's give it a header. So let's date it. What's today's date? 11/6. We got 11/6/17. We're on 3.3.1 on our topic today, which is worth documenting because it's a really important word, is rational values. Rational values. Or numbers. And I'm going to give you the easiest, most simple definition I can, because I'm here to make your life easy. We need this in our notes. We need this formally written down, what it means to be rational. Now, you've probably heard rational or irrational used in ways that are not necessarily mathematical. Don't you ever have a friend or a parent or somebody be like, well, that's just irrational, or that idea is irrational. Or somebody say, come on, be rational. Make a rational decision here. So this word gets used a lot, but it has a very specific mathematical meaning. At the root of the word, what word do we see hidden within the word? Ratio. A rational number just has to satisfy one condition. Can be written, and you could really abbreviate that however you want. Can be written as a ratio. The even easier way to say that, or the way that will make absolute sense to you, can we represent it as a fraction? A fraction is a ratio. A ratio can be written as a fraction, but a fraction is a ratio. It's a comparison. 1/2 is 1 to 2. 3/4 is 3 to 4. It's comparing part to whole, or part to part. So rational numbers can just be written as fractions. So when we start looking for rational numbers like we do in 387, when we look at 2 divided by 8, so let's go ahead and label on our notes that we're going to look at 387 now. Any question on rational numbers being written as fractions? They are ratios. I want you guys, as your groups, check out I, double I, and triple I. Are those rational numbers? Can they be written as a fraction? And mixed numbers and improper fractions, those are all still fractions. So mixed numbers and impropers, they're all fractions. So try it out. I through triple I. So I is the easier one up here, right? So I went ahead and gave you that one. Double I and triple I are a bit more complicated. I just comes down to a reduced form of 1/4. You seem really quiet today, so maybe we'll just use some cards and talk to some people. Mr. Cooper. Where are you at? Mr. Cooper, can I write 72 divided by 5 as a fraction? What goes where? Does my 72 go on top or bottom? Whatever comes first goes on top. So when I go to write 72 divided by 5, everybody in their notes should have 72 over 5. Now, how do we reduce fractions? Patrick? Yeah, you're kind of... We want to divide by something common, right? So we divide by a common factor. Careful, because factor is what you can break things up into. So we look for a common factor. 72 could divide by 2. 5 can't. 72 could divide by 3. 5 can't. 72 could divide by 4. 5 can't. And 72 cannot divide by 5. Correct. 70 could divide by 5. What would 70 divided by 5 be? Break it up into the 50 and then the 20. What's 50 divided by 5? Yeah. So if we break this up, here's our 70 divided by 5. We get 10 and 4. So we get 14 and a leftover 2/5. Now actually, this right here, 72/5, we could stop there. That is a rational number. Improper fractions are rational. They're fine. As long as we have an integer in the top and an integer in the bottom, entire value, 72, 5, both integers, that's a rational number. This is still rational, just mixed, but it's still irrational. 51 divided by 94. So I can stack it vertically, 51 divided by 94. Common factors. I'm trying to think, what can I divide 51 and 94 by? Do we need to? We could just stop right here. That's a rational number. That shows it can be written as a ratio. We can stop right there. Now, if we want to try to go further, we can, but we don't need to. And then we could use the calculator to convert if we wanted to. Think about C for a minute. Talk with your group, please. We did not really start talking in the last one. Why can't the denominator be 0? So if you can't figure this out as your group, talk about what is the denominator, what is division, what is a fraction, what is it representing, what are we doing with it, why can't I have a 0 on bottom? Take a couple minutes to talk about that. Francesco, when we talk about division, what is division? How could you explain, like, say an alien popped down here into our math class. How do you explain division? Like, so the alien looks at this problem, and they ask you to make sense of it. 8 divided by 2. How could you give them, like, a word problem or situation to explain to them what that is? Okay, how would you describe it?
Well, it's kind of a mix of multiplication and subtraction because it's how many times 2 can go into 8 and then eventually getting that number, but it ends up being less than what you started.
Okay, yeah.
Good morning, Nathan Wirtz. Please come to the office. Nathan Wirtz.
Saw a couple of hands floating
Thank
up.
you.
Annika?
It's grouping a certain amount of numbers from
Yeah, that works too. It's, and I'm going to put a little preface in. It's regrouping, because you say grouping from the beginning. So we take what we start with and regroup it. Division is just splitting up, right? I have something, I'm going to break it up. Now, we can either think of this as 8 make groups of 2, right? I have 8 cookies. I want to make groups of 2. How many groups of 2 could I make? 4, right? We know the answer to this. You're all sitting here like Monday morning, really not wanting to participate. But if I make 8 and split it into groups of 2, or what if I say 8 only into 2 groups? I still get 4. So this can either be how big the group is, or how many groups. So what if I come up here? I have 7. I'm going to break it up into 0 groups. I have 7. Right? I have 7. So, you awake this morning? Here's 7. Break that into 0 groups. What do you mean throw it away? Then you'd have a lot. They'd spread out, I think. Right now she has 1 group. What can we do, Emma? Or if groups of 0 doesn't work, make 0 groups. Or groups of 0. You can do either. Emma's just death staring me. She says, why did you choose me? Thank you. Can I take a quantity and split it, especially when we add that word? Can I split this up into 0 groups? No, that doesn't make any sense, and gravity still works. I have a group to start with. I cannot make 0 groups, especially when I split. Okay, so look at it the other way. Can I make groups of 0? Okay, 0 here, 0. That doesn't help at all, because I still have all of these. Because I'm making groups of 0 that doesn't use any of these. When you think about what it is doing, division by 0 doesn't make any sense. You're making 0 groups or making groups of 0. It doesn't make sense. So hold on to it for a second. Take a moment on your paper. For C, document somehow that you will remember, because hint, hint, nudge, nudge, this could be a test question. Why you can't divide by 0. It's impossible. Not just you're not allowed. It doesn't make any sense. So I'm going to write here because we can't make groups of 0 or 0 groups. You write whatever makes sense to you. Cannot make 0 groups or groups of size 0. Did you have a comment on that? So Grant's bringing up something really good over here. Science, if you're tuned in and awake during science, he's talking about conservation of mass. If we start with something, you cannot then, like, have nothing, right? Like, we have something. If I split it up, no matter what I do, I still have that something. I can split it into 1,000,000 groups. My groups could be itty-bitty, but I still have something in each of those groups. Thank you. That was a really good point. Conservation of mass. Think about that with division by 0. We can't make groups of 0, / we can't make 0 groups. So now on to one of the hardest, no, sorry, 88, never mind. 88 is not that hard. 89 is really complicated, but don't worry. I will walk you through it nice and easy. Talk about this with your groups. We have 4 different fractions shown up here. We have this, and I'm not going to read any of them. We have this. We have this. And sorry, only 3 different fractions. Which of these do you think? No, yeah, I missed one. So we have front, top, both, or bottom. Now, if you've ever played really old or watched really old TV or whatever, one of these things is not like the other, right? We're looking for which one of these things doesn't fit, doesn't match, doesn't behave like the others. So take a moment with your groups. Which of these do you think is not like the others? Talk to the groups. Miss Burns, have you guys decided which one you think is not going to behave like the others? Can you just take a guess of which one looks different or has something different? If not, it's okay.
I thought the first one, but like the first one and the fourth one are really similar.
The first and the fourth seem similar. Also, they seem different than the other 2. They seem different than the middle. I like the observation. Ella, what do you think? Miss Gibson? First one's at why do you say that? Okay. It's in front as opposed to in it. I like that observation. Kate, what do you think?
I think the first one too. All the other ones do have the negative.
Okay. What? So 2 divided by 3. We've played with this a little bit. It's going to be an awkward decimal. But 2 divided by 3 on its own, if I just looked at 2 divided by 3, would that be positive or negative? Positive, right? They're both positive. I just positive divided by positive. I get positive. So what would the opposite of 2 divided by 3 be? Would it be positive or negative? Negative. Okay. What would the opposite of 2 divided by 3? Would that be positive or negative? Ooh, now we're a lot quieter. If I have a debt of $10, and I'm going to pay it off over 5 days, or I got that debt over 5 days, that breaks down to a debt of $2 each day. Debt being negative. If there's one negative, and you might want to make a note, one negative means that my answer will be negative. So we said that A was going to be negative. Now we found out, or sorry, not even A, the second one is going to be negative because negative 2 over 3. Aubrey, what about my third one here? 2 over negative 3. Is that going to be positive or negative? How many negatives does it have in it? So, is it going to end up positive or negative? Which do you think? Think about the rule we just wrote down. How many negatives does this have? 1. Right? 1 negative tells me that my answer will be negative. Now, just like we did last week with multiplication, remember, division's the same as multiplication. Last week we talked about, Marvin, what's the opposite of a negative? Positive. He says, like, well, of course. What's this one going to come out to be? Positive. This guy is not like the others. All the other 3 situations will come out to be negative. But when we have a negative divided by a negative, it's positive. So all 3 of these situations are equal to each other. These are all the same. They are not equal to the 4th one, because this guy comes out to be positive. The big thing to take away from here, where the negative is located. If there's one negative out front, in top, or on bottom, doesn't matter where it is. It makes the fraction negative. Any questions with that? All right, now here's where you really need your graph paper. So moving on to 389. Please number this where you have space on graph paper to work, that we're working on 389. And please write down that math, 1 3/8 divided by 3/4. So the problem we have here, 1 3/8 divided by 3/4. Now always, even before we model this, I have made my stance very clearly known. I don't like mixed numbers. Right? Not that I hate them. Hate's a really strong word. I just don't like them. They're harder to work with. What do we say, or at least I say, is better than a mixed number? Alan?
Improper.
How do I make improper?
Multiply 8 and 1 and then add 3.
Thank you. So when we make this improper, 8 times 1, then add 3, what do we get? 11. So we get 11/8 divided by 3/4. Go ahead and rewrite that. Probably below it will make it make the most sense. If you struggle at all with the improper conversion, please draw the arrows showing that we multiply and then we add. We're now going to draw this. So on your graph paper, please watch me for just a second. I'm going to start somewhere, and that's my 0. I'm then, we got to be precise with this for it to make sense, going to count 1, 2, 3, 4, 5, 6, 7, 8, and that's going to be my 1. But I need to go beyond that because I need to show 11/8. So I'm going to go 9, 10, 11. There's my 11/8. Each of these boxes on your paper is going to represent an 1/8. So that'll be a half. Go ahead and draw that on your paper, please. If we went out to, you can go ahead and show this if you want. The tick mark beyond where we would be 1.5. You could label that each tick mark is worth an 1/8. Any issues with drawing out what we start with, my 1 3/8? I'll put your pencil down. Once you have that, put your pencil down. Let's say I order a pizza. Right? Sorry you guys are first thing in the morning. I probably leave you hungry often. Let's say we order a pizza. How many slices do you think is appropriate to give away when you're cutting your pizza? I don't want to do that. How many pieces do you think make up a good serving? 8, right? Our pizza's normally, or not a serving. That'd be a big serving. But we cut our pizza into 8 pieces, right? Most pizza places cut them into 8 pieces. So we have 8 slices that we're working with. And I'm going to give each of you 3. So I'm going to do 8 divided into groups of 3. So I come to Annika, because a beautiful smile this morning. I give her 3 slices. Slice 1, slice 2, slice 3. Those go to Annika. And then I move on to Nathan. And I give Nathan slice 4, 5, and 6. Then I move on to Francesca, and Francesca's already kind of got a pouty lip on, because she knows what's about to happen. Francesca, what's about to happen? You're not going to get as many pieces. Now, can Francesca still get pizza?
Yeah.
Yes! How many slices? 2. Now, how many slices was she supposed to get? 3. So what could we say about Francesca's serving? She got what fraction of what she was supposed to get? Grant? Well, okay, so she got the remainder of our problem, but can we quantify it? Can we actually say what fraction she got? Ooh, not 2. 2/3. She wanted 3, but she only got 2. So Annika and Nathan got their servings. We got 2 servings, but then Francesca only got 2/3 of a serving. Now here's what I'm trying to get you to see. What she ate. These are each 8s. But when I look at it relative to what she wanted, she didn't want 8. She wanted 3. She got 2. That's where 2 out of 3 comes from. What she was able to get left over out of what she was supposed to get. Now we're going to look at this a tiny bit harder. So, on our math, what we're doing starts with the entire quantity 1 3/8. This is like our entire pizza. This is what we start with, this entire region up to that tick mark. Right? So we can, if I highlight that just yellow to be nice and easy, we start up to here. Right? That's how much we have. We want to make groups of what? How big of a group does it tell me? Divide by what? Divide by, what are we dividing into? Like we divided by 3 slices. What are we dividing by here? 3/4. Right? So instead of the group being a whole amount, now my group is 3/4. Now wait a minute. Am I working in 4ths? I need to come up here and make my life easier again. This is working in 8ths. Let's think in 8ths. You don't have to do this, but you should. This is a division technique you don't have to do, but you should. 3/4 I can actually convert into 8ths by multiplying by a giant 1. What giant 1 would get me into 8ths? Marvin? 2/2. So this I can actually think of as 6/8. 3/4 is 6/8. All I did was convert. Now we need to show the groups of 6/8. So we start at 0, show this, please, and if you need to use colors, you can. Come grab a colored pencil. I go 1, 2, 3, 4, 5, 6. This is group 1. It is 6/8 big. So that counts as a whole group. We get 1 then. That's like Annika's pizza. She gets her first serving. We move to Nathan. Try to get our second group. Do I have enough to still have 6/8 left? Well, go out to the end of your yellow. Now I'm going to change color and do group 2. 1, 2, 3, 4. Crap. Do I have an entire group? No, so this is going to be a partial. How many pieces did I want? Like, how big is group 1? How many pieces? 6 pieces, right? I wanted to get 6. I didn't. How many did I get? Check again. 5 out of how many did I want? This group becomes 5 out of 6. We wanted 6 of the 8s. I only have 5 of the 6. Even though each of them are an 8, these spots are 8s. The partial group I get is represented by 5, 6. So the answer here becomes 1 and 5, 6. All of that is shown in your book, but I need you to understand how we get there. So check this out, because it's in your book and we only have like 8 minutes of class time left. So right here, Ramona draws out the number line, counts out 6 of the 8s, stops it right there, then counts out 5 more, realizes that there's 5 8s, but the problem is that is 5 8s, but that's not the size of the group. The size of that group is 5 out of 6, what we had initially wanted. Madison does her work in a slightly different way, saying how many times can 6 go into 11? Because if I look at 11 8s compared to 6
Good
8s,
morning, Lindsay Findell. Please come to your locker. Lindsay Findell, please come to your locker. Thank you.
what Madison really did was count how big the starting group is. So if she pairs up with Ramona, she goes to Ramona's graphic and says, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 11. I'm trying to make groups of 6. So Madison just says, well, if I have 11 sections and I divide by 6 sections, well, here's an entire group. And then I don't have an entire group here. That becomes 5, 6. So Madison took a slightly different way. And again, you have all of these in your book to refer back to. Hugh does a different way that is super simple. Has anyone ever heard KCF or keep, change, flip?
Yep.
Okay, now this is really bad because you probably have no idea why.
Kentucky Chicken.
Right, but why? So, what we're doing with the keep, change, flip process, I'm going to throw this back up onto the screen. Please write out again 11 8ths divided by 3/4. We're going to go to a new page. Write out again 11 8ths divided by 3/4. Just like if we had a really simple problem, like 8 divided by 2, I could really quickly make that 8 over 2. And then I get to a point where I have 4 over 1, and that's my answer. Great, my answer is 4. But here, if I take 11 8ths and put it over 3/4, it looks messy. 11/8 over 3/4. So that's a compound fraction. Fractions involved in fractions. It's a fractionception. It's an inception of fractions. Fractions inside of fractions, compound fractions. Our goal with any division problem is make it not division. Solve it, right? What we end up with here, does dividing by 1 do anything? No. So what we want is a 1 in the denominator. This was part of your homework. It was in your your toolkit. It's also in your math notes box in your textbook. The way we turn a fraction into 1. Does anybody know? Anybody do that homework really well yet? Alex?
Good morning, Phoenix.
Close.
Please pardon the interruption. If anyone has money for Turkey Bowl, please make sure that is turned in today. Again, if you have money for Turkey Bowl, please make sure to turn it in today. Thank you.
Patrick? How many halves make a whole? 2, right? How many fourths make a whole? How many eighths make a whole? 8. When we want to turn something into a whole, multiply by its reciprocal. Can't write today. Which reciprocal, all you need to remember is reflip-rical. You just flip the fraction. So we want a 1 on bottom. If on bottom I have 3/4, multiply by 4/3. Now if I do it on bottom, I got to do it on top. This is a giant, giant 1. Please show this in your notes. You can also label somewhere this is kind of the KCF process, kind of. Not exactly, but kind of. Yeah. Yeah. Now, the denominator, a number times its reciprocal, will make 1 in the denominator. My numerator, multiply straight across the top in the numerator, straight across the bottom of the numerator. What's 11 times 4? 44. 8 times 3? 24. When we reduce that numerator, you get 1 5/6 divided by 1. What does division by 1 do? Nothing. So I just get 1 5/6. If you can make the denominator 1, you don't have to divide. Let me look really quick at what else we didn't get to. We have 4 minutes left, so we're not out of time yet. Try these 2 down here really quickly. The 4/5 divided by half and the 2.5 divided by 3/4. Up on the TV. Think about the division problems. You have 4/5 of something, less than 1, and you want to make groups that each are a size half. How many groups do you think you'll be able to make? How many halves do you have in 4/5? Do you have 1/2? Think about modeling 4/5. So if this is 0 and this is 1, 4/5 is something like, I don't know, here-ish, right? It's less than 1. Think this through. If I want to make groups that are the size of 1/2, well, there's like 1/2. Can I do the next half? No, I'm going to run out of my 4/5. So this will be 1 and something if we apply that KCF process, what Hugh did last time. And we'll do more of this together. Our answer here will become 8/5, which is 1 and 3/5, which tells you this little extra out here is actually 3/5 of another group. Please try your homework. We cannot figure out what you can't do on your own without you trying to do it on your own. We'll start class with questions tomorrow. I do not have stuff up for you to check yet. That's intentional. I just want you guys trying stuff on your own right now. Nothing to check. Thank you guys very much. Have a good day. If you have stuff to turn in, please get it back to me as soon as possible. Enjoy your Monday.